the safety and security concerning lithium-ion battery systems is a vast topic to cover in this sort of time span. But here is actually how a lithium-ion battery works. We start off with a fully charged anode material where all the lithium atoms are present and chemically bound to the anode material. Most often it's graphite. And then we have a depleted cathode material where when the lithium ions or lithium atoms are migrating to that side, they are more tightly bound. And this is what happens during that. Here. The lithium ions are migrating within the battery through what's called the electrolyte and ending up on the cathode side. And with current, the electrons are migrating in the external circuit, doing the work, for instance, powering the engine of an electrical car. Let's do it one more time. So here, lithium ions are migrating, and the electrons are moving in the external circuit until each of those has arrived on the cathode side of the battery, and then the battery is charged. And by adding energy, those lithium atoms will return to the anode side for further use, so to say. So, and the losses in this circuit, in the external circuit for the electrons, is negligible. Roughly 5% losses in each of those charging cycles. And those losses comes from the lithium ions migrating within the electrolyte through the battery. And that will cause heat to be produced. And heat is a huge problem in batteries. There are a lot of commodities used in manufacturing batteries. We have metals, for instance, copper on the anode side of the battery, aluminum foil on the cathode side. We have electrochemical active material, granules of graphite, and most often metal oxides on the cathode side of the battery. But there are a vast number of additives, binders to keep all those micrometer, nanometer sized granules bound to each other. We have the electrolyte, that is in most cases a liquid. And liquids could, if heated, result in vaporization. And vapor, a gas, puts pressure on the battery internally. So the casing of the battery could rupture. We'll look into that further on. So there are several, and one of the additives used in electrolytes to stabilize the chemistry is a fluorinated, rather nasty chemical compound. And fluorine, when heated enough, will produce hydrogen fluoride, a highly toxic and corrosive gas, could cause chemical pneumonia. The fluorine is needed to stabilize, in most chemistries, needed to stabilize the battery chemistry, but as a side effect, if combusted, will produce hydrogen fluoride that is highly hazardous to health, of course. And we also use some fluorinated binders to keep those granules on the cathode side bound to each other, electrically connected. And a lithium-ion battery cell is a sensitive flower. It's easy to go out of range, and the ranges are in this picture you can see from 2.2 volts to 4.2 volts. If you go below or above those settings, you will cause degradation and hazards. You will permanently damage the battery cell if you go out of range on the voltage scale. And here we have a temperature range from roughly minus 20 degrees to 80 degrees centigrade. That's the window of operation for a lithium-ion battery cell. And it is hard to keep that battery cell stable. When used during charging or discharging, that small internal resistance will heat the battery and could potentially cause release of flammable gas, venting, and thermal runaway. And that is, of course, a highly highly hazardous event. Should be prevented at all costs. So how is this managed? We are using a battery management system to increase cooling if the battery is getting too hot, or increase heating if the battery is too cold. And that is done by clever software. And to prevent the battery from dropping too low, yeah, you will look into your state of charge meter in your car and see that, yeah, you should stop for a charging of your battery within a certain time span. And when fully charged as well, you have to limit the energy you put in the battery, or in extreme cases when you're discharging the battery also. So clever software to keep that window of operation stable and prevent the battery cell from going outside that interval. So what happens if you don't manage a battery properly? Yeah, battery cells, they don't die, they get murdered. Sorry to say, if you look to the right, the three necessary components to produce a fire is present within the battery. You have heat produced from the internal resistance of the battery cell, you have fuels, combustible liquids like the electrolyte, and you have oxygen present. In most cases, on the cathode side of the battery, you have metal oxides, and oxides, yeah, you get a lot of oxygen present. At high temperature, everything needed for a full-blown fire, a thermal runaway, is present within the battery. So it's hard to keep a battery stable. Could initiate by a slightly too high current that will cause localized heating of the battery, that will cause the separator, the membrane that keeps anode and cathode material separate. So that, and that is often plastic or ceramics, or a mixture of plastics and ceramics, and they will melt. And then you will have a short circuit. All that precious energy that could result in a current to be managed through the electrical machine, producing torque and power for the car, will be released as heat instead. And then you will have a massive increase of heat production and the risk of getting into a full-blown fire.